Hi, how are you? Today we will see something different. You can see the heading. What is the heading? Mass into acceleration is not a force, and therefore m into g means mass into acceleration due to gravity is not a weight. We will see. But generally, what is our method? Generally, we enjoy some experiments before learning the concept. In this case, there is no experiment because we already have seen the law. Which law? Newton's second law. What is second law? Acceleration is directly proportional to force and inversely proportional to mass. That force is net force. Remembered? Okay. This is statement form. Now I want equation form from Newton's second law. Then you can replace this proportional sign with is equal to sign. Then it becomes equation, means it equates something. Remember this term. This equate these two terms. This k is proportionality constant. Now value of k is taken 1 for simplicity. This is simple reason. How it is taken 1? In 1948, there was a conference on weights and measure. In that conference, unit of force was standardized as 1 Newton. And that 1 Newton is that magnitude, that amount of force which accelerate a body 1 meter per second square if its mass is 1 kilogram. That is the definition of 1 Newton unit. After 1961, SI unit is taken all over the world, but in 1948 there was no SI unit. Okay, that's why I have not written SI unit. I have written only unit. Remember. Now, after taking k is equal to, this equation will become very simple. A is equal to F upon m. Now, what we have studied, acceleration is directly proportional. Okay. Now, in this case, this acceleration is equal to force upon mass, but this A is not F upon m. Means there may be somewhat contradiction. Here I have written A is equal to F upon m, force upon mass, and here I am saying that this acceleration is not force upon mass. Then what is this force upon mass? It is something different. This is not acceleration. Force upon mass is not an acceleration, because you know very well that acceleration is rate of change of velocity per unit time. Means change in velocity divided by time. This is acceleration. This is not acceleration. If this is not acceleration, then you can't say force is mass into acceleration. You can't say. Force is equal to mass into acceleration. But this mass into acceleration is not force, remember. Then what is this? What is this? Now we will get acquainted with these new quantities. Now acceleration is change of velocity per unit time. Then you can write in equation form as dv by dt. This is derivative form. After this video, there will be calculus video, okay, and it is very easy, and there is some beauty of calculus, very interesting, and you know very well what is calculus, what is differentiation, what is integration. You know very well, whether you are in 8th standard or whether you are not taken science in your life. We will study. This acceleration is d by dt. Then you can say acceleration is rate of change of velocity per unit time. But this F upon m, from this equation you can say A is equal to F upon m. From these two equations you will say LHS are same, then RHS must be same. Then you can write dV by dt is equal to F upon m. Concentrate on this formula. This dV by dt is acceleration, and this F upon m is cause of that acceleration. Remember this one. This is cause of acceleration and this is acceleration. Means you can never say that F upon m is acceleration. You have to say force upon mass is the cause of the acceleration. Why? Because suppose I am pushing car, means I am applying force, means force is cause, that's why I will get acceleration of car. Car is accelerating and that's why I am applying force. This is not correct statement, that sequence is not correct. There must be some cause, then you will get effect. Therefore, this force and this mass combinedly you can take cause. This cause produces some effect, that is called acceleration. Means quantity wise these two are equal. Quantity wise you can say these two are equal. This force and this mass into acceleration quantity wise same, because this is force but this is not force, this is effect of force. If this is effect of force, then what is force? We have not studied force in first, second, third law in our videos, not in fourth video also, because those laws are not laws of force. I have explained. Therefore, remember this is effect and this is cause. For example, I have taken mg is not weight. Then what is mg? Mg is the effect, because you can see here mg is equal to F. This F is gravitational force, I accept. That is gravitational force, you can write here. But this gravitational force is mg, or this mg is gravitational force, I will not accept. Quantity wise both are same. This is cause, this is effect. Means formula of G will be G is equal to, okay, I am shifting here, this mg is equal to what I have written? This mg is equal to gravitational force. Mg is equal to gravitational force, means it is indicating equality. Means mg is not gravitational force. Suppose I have written this formula, G is equal to F upon m gravitational. We will see what is actually gravitational force in next video, but this gravitational force is exerted by earth on body having mass m, which produces acceleration, and that acceleration is indicated by this small g. Actually a must be the symbol, but for gravitational acceleration G is taken as symbol and its value is 9.8 meter per second square. But gravitational force and mass having units, just we have seen that unit of force is taken 1 Newton in 1948, means you can write here unit as Newton and unit of mass is kilogram. Unit of acceleration is meter per second square, not Newton per kilogram, but mathematically you can show, or in the form of equation by using physics you can show 1 meter per second square is equal to 1 Newton per kilogram, but you can't say meter per second square is Newton per kilogram. This is different physical quantity. This physical quantity is called gravitational intensity. Gravitational intensity means this is not acceleration, this is gravitational intensity. And don't get confused that acceleration is F upon m, because this 9.8 meter per second square for gravitational means I have taken example for gravitation. This 9.8 for earth, it is fixed on the earth surface. If mass is more, suppose it is 100 kilogram, then force on that mass will more or less, force will be more, means you can say if this is 100 times is more than this one, then this is m into 100, then actually I have taken 100 times more mass, that's why force will be more by earth, so that its effect will be same, effect will not change, means that body is also falling with 9.8 meter per second square, effect will be same on heavy body, on light body. Therefore, that small g is acceleration, but this F upon m is not an acceleration. Now, generally we say that, means physics teacher said, what is the formula of force? A formula of force is ma, mass into acceleration. Actually, we should have said that what is the formula of effect of force, then you will say mass into acceleration. Then actually what is the force then? What is actually force? That force we will study in next video. But after this, there will definitely on calculus only. Means 2 or 3 videos will be on calculus, and that calculus is related to your day-to-day life, and it will be converted into physics or mathematical formula. Okay, till then take care. Thank you.